Hi, welcome back. Let's go ahead and continue on in section 7.5, which is where we were solving equations, meaning it has that equal sign, and we actually get like x equals something when we solve it. Okay, so earlier in the unit, we talked about factoring, just polynomials, and we talked about like the difference of squares, which was two terms that were squared and separated by a minus sign. We talked about factoring by grouping, which was four terms. We talked about just finding the greatest common factor in a polynomial. We talked about trinomials, which is three terms, where the leading coefficient is greater than 1. We had to break apart that middle term and use factoring by grouping. Or where the coefficient was equal to 1, that's where we could jump to the shortcut. And then finally, we moved on to 7.5, which is solving the equations and using that zero factor property. So hopefully this problem right here is a review. So just continuing in the packet, solve x squared plus x minus 6 equals 0. So go ahead and give it a try, see if you remember what to do. Hit pause, press play when you're ready. All right, so leading coefficient is equal to 1, meaning we can jump to our shortcut. We want to find two numbers that multiply to negative 6, but add to 1. So it's going to be a negative 2 and a plus 3. Two things multiply equal to 0, so we set them both equal to 0. And go ahead and solve. So we get x equals 2 is one possible solution, and x equals negative 3 is a possible solution. So both of those, if you plugged them back into your original problem, you would get that it equals 0. So 2 squared plus 2 minus 6 is 0, and the quantity negative 3 squared plus that negative 3 minus 6 would also equal 0. So in general, we've just been solving these things, but we haven't really been talking about the big picture. What is it that we're really talking about? So I've actually included a graph here of what x squared plus x minus 6 looks like. Okay, so it's just a parabola. It looks like a U. And when we're talking about it being set equal to 0, on our graph, where is 0? It's right here, that x-axis. That is our x-axis. Okay, and when that is set equal to 0, do you see where this parabola is crossing the x-axis, where it equals 0? It's crossing right here at 2 and at negative 3. So those are our solutions. That's what we're doing, is we're looking at a picture of a parabola. We're solving it, which means we're finding where it equals 0. We're finding where it crosses that x-axis. And then I just kind of zoomed in here so you could see it again. Again at 2 and negative 3. And so what do you notice about your solution when you factor the equation or the graph crosses? That the solution, I'll go ahead and write this. The solution is where y equals 0 at the x-axis. At 2 and negative 3. All right, let's look some more at graphs. So go ahead and turn the page. And for this top section, I have used this graph. So here's my graph of y equals a negative x squared minus 4x minus 1, shown in the figure below there, to solve the given equation. So every single one of these problems, you'll notice, starts with that negative x squared minus 4x minus 1, the 51 through 54. So that is that picture. So we're trying to figure out where y, so y is here, right? This is your y-axis, where y would equal that 2, 4, negative 1, and 3. Okay, so I'm just looking at where it equals these numbers. So I'll do the first one with you, and then I'll ask you to do the other three. Okay, so in the first one, it says that the equation that they gave us, that negative x squared minus 4x minus 1, where does that equal 2? Okay, so I have my y-axis, so I go to 2. I'm going to fill in these numbers here for us. I go to 2, and I look across. I just kind of like to make a little line just so I can see it. This parabola is equal to 2 at two different values. Do you see where it's crossing, where it equals 2? At negative 1, it equals 2. and again at -3. Okay, so the solution of -x² minus 4x minus 1 equals 2, we found that by looking at the picture, finding where y is equal to 2, and found that those x values, if we look down here, they were at -1 and -3. Go ahead and try the next 3 on your own and come back and see how you did here in just a couple minutes. All right, the next one is at -1. So I'm just going to go to -1. I'm going to put in a line here. And I can see the solutions are at 0 and -4. For the next one, where is it equal to 4? So I'll go to 4, draw in my line. It's never a solution, right? So the answer to 53 is no solution. One more. Where does it equal 3? Just one solution right here at -2. So if you think back to yesterday, some of our answers had 2 answers, right? Which is the typical parabola. It's crossing that x-axis twice, but occasionally we had it happening just once, right? So that means in that case, in the ones that we were looking at yesterday with the 0, that would mean if we had our parabola like this, it would just hit that x-axis just once, just kind of kiss it. So that would be the single answer. That's what that would look like compared to just trying to connect up what we're doing right now to what we did yesterday. All right. Now, let's look at it in the case of a table. All right, so we have solved the given equation by referring to the solutions of this equation. So y equals 2x² minus 8x plus 10 shown in the table. Okay, so each of these, again, are the same, and we're just looking for where is it at 4, where's y at 2, 10, and -3. So I'll do the first one, and then I ask you to do the next 3. So where does it equal 4? So we look in our chart, here's y. I'm interested in where it equals 4. So here I see a 4. X would be equal to 1 is one possible solution. So if you were to go back and plug in 1 into this equation, 2 times 1 squared minus 8 times 1 plus 10, it would equal 4. There's another one. Do you see the second one? Right here at 3. So the solutions where this polynomial is equal to 4 are when x is equal to 1 and 3. So go ahead and try the other 3. Come back when you're ready. All right, did you find where it's equal to 10? There should be 2 of them, right? It is at 0. And is there another one? There it is at 4. And where is it equal to 2? There's only one of those. It's y is equal to 2 when x is 2. And finally, how about that last one? Where is it equal to -3? I don't see any -3s in there, so this is no solution. All right, let's keep on going. This one says find all x-intercepts of the graphs of the following equations. So it's the same thing here. The x-intercept is happening where y is equal to 0, right? So our first step is just going to be writing in 0 equals x squared plus 4x minus 45. Okay, so go ahead and try that one. Solve that one. Also try number 13. Then we'll come back together and see what happened. All right, so I went ahead and factored, and the leading coefficient was 1, so I could jump to my shortcut. I wanted two numbers that multiplied to negative 45 but added to 4, so I got 9 and negative 5. Set each of those equal to 0, and my solutions are negative 9 and 5. Now there's one little tricky part that I want to point out, is that this did say find the x-intercepts, and whenever it talks about intercepts, it's talking about what does the picture look like on the graph. So where would that be? What would the ordered pair be? Okay, so if it says x-intercepts, what you do have to do is actually write it as an ordered pair, which will just be negative 9 is x, comma, y is 0. Okay, so our ordered pairs are x, comma, y. So our x is negative 9 when y is 0, and 5, 0. Okay, so you do have to do that whenever it says x-intercepts. Okay, so on the next one, set it equal to 0. Jump to the shortcut. Looks like a minus 5 and a minus 5. So x minus 5 equals 0. X equals 5, written as an ordered pair, would be 5, comma, 0. Next, it says a cubic equation in one variable is an equation that can be put into the form. This is ax cubed plus bx squared plus cx plus d equals 0, where a, b, c, and d are constants, so just numbers. And a does not equal 0. So here we have some examples. So the cubic, it just means that your highest exponent is at 3, and a could not equal 0, because if it did, if that first term was 0 instead of a number, it would wipe out the cube and it would just be the squared, right, the parabola. Okay, so now we're going to solve these. So same thing that we've been doing, okay? First, what do we do first? We look for that greatest common factor. So is there anything that we can pull out of this number 14 for all of our terms? How about 5x? And what we're going to be left with is x squared minus 6x plus 8 equals 0. Go ahead and try to finish this problem off. Also, give number 15 a try. All right, so I'll bring down my 5x. What's in parentheses here is leading coefficient of 1, so I can jump to my shortcut. And I get a negative 4, a negative 2. So setting each of these equal to 0 would be 5x equals 0, x minus 4 equals 0, and x minus 2 equals 0. 5x equals 0 means that x is equal to 0. X minus 4 equals 0. Solving that, we get x equals 4. And x minus 2 equals 0 is x equals 2. So now in this case we have 3. So the cubic, in this case, it is crossing that x-axis 3 times. Okay. I'm going to do a quick little sketch, just a very rough sketch. If you want to just type into Google like a free graphing calculator to see what any of these look like, it's super easy. Okay, so I've done it real quick with this one. I'm just going to try to sketch what I got. It went through, let's see, it goes through the 2 and the 4. And my graph that I got, it looks something like this. It goes up and then back down, and then it goes back up again like that. So it's crossing at the 0, at 2, and 4. So that's what that equation looks like. I just typed it in real quick to see what it would look like. So it's crossing 3 times at 0, 2, and 4. All right, the next one, we want to set everything equal to 0. So we'll do that first. And then we'll factor. I don't see any greatest common factor. What I do see is 4 terms. So what does that mean? That means factoring by grouping, right? So I'm going to group these first 2 and these second 2. Out of the first 2, I see a k squared is in common, leaving me with k plus 2. And in the second set, I see a minus 4 is in common, leaving me with k plus 2. is equal to 0. Bring that common factor, that k plus 2 out front, leaving me with k squared plus, k squared minus 4. There we go. That k plus 2, that is factored. I can't do anything else with that. Can I do something else with this? Do you recognize this? Difference of squares, right? Something squared minus something else that could be squared. So that is going to be broken down even further into k plus 2 times k minus 2 is equal to 0. Set each of these equal to 0. The k plus 2, we have 2 of those, so I'm just going to do it once. It would be silly to do that twice. K minus 2 equals 0. So I get k equals negative 2. And k equals 2. All right. If you want to, you could go Google that graphing calculator and type in this guy and see what it looks like. Because we said the cubic, it's probably going to have 3 answers. So if you want, I go type that in if you're curious to see what that would look like when you only get 2 answers for a cubic. Okay? Next, going to finish off this page here. We have to solve a quadratic or cubic equation in one variable. Write the equation so that one side of the equation is, what do you think? What did we just do? We made sure that one side of the equation is equal to 0. Then we had to factor the non-zero, because one was equal to 0, right? Had to factor the non-zero side of the equation. Apply there's a property, what do we do? It's called the zero factor property. And then we had to solve each equation that results from using the zero factor property. All right, one more page for today, okay? These next ones, 16 through 19, actually this whole page, because you can answer that bottom question too, it looks like. Go ahead and try to do this whole page on your own. Okay, so I'd say give yourself probably like 10 minutes or so. Just hit pause, come back when you're ready, and then we'll talk about the purpose of this page. Okay, so hopefully you figure it out as you're going along. Go ahead and give it a try. Hit play when you're ready. Okay, so this first one, 16, it says to factor x squared plus 5x plus 6. So if I factor, leading coefficient is 1, I can jump to the shortcut. I'll lay that out. 2 numbers that multiply to 6 but add to 5 are a positive 2 and a positive 3. Can we go any further? We cannot. We're just factoring that expression, okay? We're done. We factored it. In 17, what do you notice? It's the same as 16, but now it's an equation. It's an equation because it has this equals. Okay, so if it has the equals, that means in the end we should have x equals something. Okay, because of that equals. So we just factored it, so we'll just copy that down. X plus 2, x plus 3 is equal to 0. Now we have it equal to 0, so we have to actually solve it. Okay, x plus 2 equals 0. X plus 3 equals 0. Meaning that our solutions are x equals negative 2 and x equals negative 3. Okay, so if it has the equal 0, your answer should have x equals something. If it doesn't have the equals, it's just an expression and you're just factoring it and then you're done. Number 18, x squared minus 4 equals negative 3x. What should I do first? Add that 3x to both sides, right? You can write it in there if it helps. Add 3x. So we get x squared plus 3x minus 4 equals 0. Go ahead and factor. Leading coefficient is 1, so I can jump to the shortcut. 2 numbers that multiply to negative 4 and add to a positive 3. I get positive 4 and negative 1. set each of those equal to 0 and solve. So I get x equals a negative 4 and x equals 1. Number 19, factor. So there's no equals, so we're not solving something. Do you recognize that yet? Two terms subtracted by a minus, that's a difference of squares. So it's going to be x plus 2 times x minus 2. Would it be correct if you put x minus 2 times x plus 2? It would, because the order of multiplication doesn't matter. And finally, last thing before we're out of here for today, what is the difference between solving a polynomial equation and factoring a polynomial expression? Okay, so solving will have x equals. Okay, so that's your equation. So you solve an equation. Also, I'm going to write this down too. Easier to solve fraction problems because the equation can be, I'm going to put scaled up. So remember when we kind of blew up those ones with the equation with the least common multiple. Okay, so that's just it, just a reminder for you. If you have the fractions with the equations, you just multiply by the lowest common multiple, and that will wipe out all those fractions for you. Pretty cool. All right, tomorrow we are going to come back and work on 7.6. And usually for 7.6, I just hand this out in groups and just have students talk about it for 20 minutes, a half an hour, and just try to figure it out. So maybe even before you hit play on the next video for 7.6, just really try to get into these problems and try to figure out what are they asking and see how far you can get. Okay, so you have all the skills that you need to do 7.6. It's just taking what we've been working on and applying it to a story problem. All right, sound good? Awesome. I hope you have an amazing rest of your day.